Hey, what's up guys? It's Miss Ludo. This week we're going to start exploring equivalent expressions, starting with simplifying expressions by combining like terms. Before we get started, let's review some important vocabulary and take a look at the different parts of an expression. So first of all, an expression is a math sentence with numbers and operations, but no equal signs or inequalities. So this is different than the equations and inequalities we've been looking at because we don't see an equal sign or inequality. A letter that represents an unknown number is called a variable, and we're pretty familiar with this after all the time we spent writing and solving those inequalities and equations. The number that is attached to the variable is called our coefficient. And I always remember this because co means with. So we think cohabitate, co-work, cooperate means with. So coefficient is the number that is with the variable. A constant is the number that stands in isolation or all by itself. So an example of this would be 3. 3 is a number that stands by itself. It does not have a variable attached to it. I also remember this because constant means stays the same. So 3 is always going to be 3. It's going to have the same value. The number of items separated by an addition or subtraction sign are called terms. So let's take a look at what all of these different vocabulary words look like in an actual expression. So over here we have the expression 5x plus 7. So in this expression, 5 is our coefficient, that's the number with the variable. X is our variable, a letter representing that unknown information. And 7 is our constant, that number stands by itself, and 7 is always going to have a value of 7. Within this expression, we have two terms. And the first term here is 5x, and our second term is 7. Those are the things that are separated by that addition sign in that expression. And this whole thing, 5x plus 7, is our expression. And notice that you don't see any equal sign or any inequality symbol there. So now that we've got a good review on that vocabulary, let's take a look at what it means to simplify an expression and how we are going to simplify expressions that have like terms. So simplified expressions are expressions that are condensed or shortened, and they're written using the fewest possible terms, and that's our key there. We want to shorten those expressions, so we're using the fewest possible terms. So expressions that are simplified are always equivalent to the expanded form of that expression. So when we rewrite these expressions using fewer terms, we're not changing the value of the expression, we're just changing the way it looks. So like terms are terms that share the exact same variable. And we'll look at some examples of this as we work through examples below. Constants, those numbers without variables, those are also considered to be like terms. And we can always combine any like terms to write shorter simplified expressions. So again, as we work through these examples, our goal of simplifying our expression is to rewrite these expressions using the fewest possible terms. When we look at example 1, we have 4x plus 3x. So in this expression, we see two terms, 4x and 3x. And we're going to break this down and think about what these terms mean. First of all, because these terms both contain the variable x, they share the exact same variable, we know that they are like terms. And we also know that we can combine these like terms to write shorter simplified expressions. So let's look at why. 4x really means 4 times x, which means x plus x plus x plus x. 3x means 3 times x, or x plus x plus x. So now we have our 4x and 3x, and we know those are being added together. So altogether, we now have repeated addition, and we're adding x 1, 2, 3, 4, 5, 6, 7 times. So we can take this expression and rewrite it as 7 times x, or 7x. This is our simplified expression. If we think about looking back at our original expression, we have 4x's and 3x's. If we look at our coefficients, 4 and 3, when we add 4 and 3 together, we end up with our simplified coefficient of 7. And we are able to do this because these are like terms, because they share the exact same variable, because we're combining all x's together. If we look at example 2, 2d plus 4d plus 3c, in this example, we have 3 terms here, but only 2 of these terms are like terms, which is 2d and 4d. So what I'm going to do is I'm going to grab a highlighter. If you don't have one, that's fine. I'll show you what you can do with just your pencil. And I'm going to highlight those like terms. So 2d plus that 4d. And notice how I also included that plus sign in there because that's going to explain to us if that term is going to be positive or negative. If you don't have a highlighter, you can simply put a circle around both of these terms. And I put the same shape or use the same color around both of these terms because they're like terms. When I look at 3c, I don't see any like terms, so I'm going to use a different color highlighter, or if I'm using just my pencil, I'm going to put a different shape around this term to show that it is not a like term for 2d and 4d. So as we saw in our first example, when we look at our like terms, we can add the coefficients on our like terms or combine those coefficients to simplify those terms. So we have 2d's plus 4d's, which means we have a total of 6d's. And since 3c is not a like term, we cannot combine it. So we'll simply write 3c. When I look at this expression, I know I can't simplify this further because these terms do not share the exact same variable and we cannot combine terms that are not alike. So this would be my simplified expression. So let's take a look at the next example. 5a minus 4 plus 3a minus 6. So I'm going to go ahead and grab my highlighter, and I'm going to highlight the first term I see in pink, which is 5a. And I'm going to check the other terms to see if any of them share the exact same variable or if they are like terms. So I'm going to highlight my plus 3a as well. These other terms that are remaining, negative 4 and negative 6, do not share the same variable, so they are not like terms. However, both of these terms are in fact constants, and we also know that constants are like terms. So I'm going to highlight those in the same color. If you guys are using just your pencil, I'm going to put a circle around my terms that share that same variable and put a box around my 2 constants. Now that I've identified my like terms, I can go ahead and combine them. So I'm going to combine 5a and 3a. 5a plus 3a would be 8a. And then I'm going to combine my blues, my constants, my boxes. Negative 4 minus 6 is negative 10. So I've now simplified my expression using the fewest possible terms to 8a minus 10. And I cannot go any further because these terms do not share the same variable. They cannot be combined. So this would be my simplified expression. Let's take a look at 2 more examples. So in my next example, negative 4m plus 2n minus m plus 3mn minus 4n. When I look at this example, I see lots of different variables here. I see m and I see n. So if I use a dime to represent m and a nickel to represent n, this is what my mn is going to look like. Is my n the same as mn? Are these the same exact variable? No, this looks more like a snowman where this is just a bigger circle. My m is also not the same. This is like the head of the snowman where this is the whole snowman. So these are not combinable. M's can only be combined with other M's. N's can only be combined with other N's. And MNs can only be combined with other MNs. So let's go through and use our highlighter or our shapes to identify our like terms. So we have negative 4m and negative m. We have positive 2n and negative 4n. And lastly, we have positive 3mn. And again, if you guys are using shapes at home, that's fine as well. Now we can go ahead and we can combine those like terms. So anything highlighted in pink, I'm going to combine together. So we have negative 4m minus m. With this, we want to be careful and remember that this really means negative 1m. So we have negative 4m's and negative 1m's. Total would be negative 5m. Now I can combine my blues. So I have positive 2n minus 4n. So positive 2 minus 4 would be negative 2n. And lastly, we have our plus 3mn, which is its own variable. And now that I've combined all of my like terms and I do not have any terms left that share the exact same variable, we've now simplified our expression. Let's take a look at one more. So in this case, we have d squared plus 2d minus 4 plus 3d minus 1. When we think about these terms that share the exact same variable, let's just take a look at this first part, d squared plus 2d. D squared really means d times d, and 2d really means d plus d. So because this is d times d and this is d plus d, these two do not share the exact same variable. They are not combinable. So let's go through and check the ones that are. So because we don't see anything else that has a squared, we know that variable is, or that term is going to be on its own. So we look at our d's and I see another term with the exact same variable here. And lastly, I have my constants, negative 4 and negative 1. Now that we've identified our like terms, we can go through and we can combine. So we know d squared is on its own. We have 2d plus 3d, which would be 5d. And we have negative 4 minus 1. And when we combine those, we get minus 5. So now that I've combined all of my like terms and I have no remaining like terms, I have simplified my expression.